On number 18, we are to determine, without using a calculator, the negative or positive value of the tangent of 192. So we just want to know whether it's positive or negative. So let's think about that. It will be helpful if you recall from our unit circle discussion the other day that all three of the big ones are, and which obviously by extension would also be for the other three. So really all six are positive for any angle between 0 and 90. And then of the three, only sine is positive between 90 and 180, or in the second quadrant, and only tangent is positive in the third quadrant. Only cosine is only cosine is positive in the fourth quadrant. So then we're going to figure out where 192 degrees is. Well, that doesn't take but a split second, because if the positive x is 0 and the negative x is 180 degrees, and let me put degrees on that now that we're in degree mode, then obviously this would be 180, would put me in the third quadrant, so positive is the answer. That's all you have to do for those. Number 22, choose the point on the terminal side of 2 pi thirds. All right, well, this one is testing your knowledge of special right triangles. And if you think about it, 2 pi thirds, if this is 1 pi thirds and this is 2 pi thirds here, which would be a decent approximation, I guess, is because pi thirds is 60 degrees, that would put this at 120 degrees. So if I'm thinking that way, then the triangle would have to be right here. And if this is 120 degrees, which it is, that would make this angle in here at the origin 60 degrees. So this would have to be a 30, 60, 90 triangle that we're dealing with. And not only do we know it's a 30, 60, 90, but we know that this is our 60 degree angle, this is our 30 degree angle. So remember, it has to follow the pattern L, 2L, and L on the square root of 3 because of this relationship. So if you look at our points, the first one is negative 1, 1. Well, if you go to the left 1 and up 1, then that means that the legs would be congruent, which would make it a 45, 45, 90. So we can omit negative 1, 1 from consideration. Well, if I try out the next point, which is negative 1, the square root of 3, let's see what happens here. If I put a negative 1 here, that gets me going in the correct direction for where the angle lands or terminates. And then if I make this my L, and then L can be 1 here, then that would give me the square root of 3 I need. So B is our answer. But let's look at why C doesn't work. Let's see if I can actually circle that. There we go. So B is the answer. But look what would happen if we went to the left. Let's sketch another triangle here. If I went to the left, the square root of 3 and up 1, then by the relationships in the 30, 60, 90, this angle would have to be 30 degrees. And since we know that this angle, for it to be 5 pi thirds, the angle back to the positive x would have to be 120. That's not possible. So that confirms that B is in fact the answer. Then we go to 28, which says, evaluate using a reference triangle. We want the cosecant of 3 pi fourths. Well, we're in the top half of the plane here because 3 pi fourths is the center of the second quadrant. So that would put us here. So this is where 3 pi fourths is. Well, that being the case, then our reference triangle is going to be right here. And by the same logic we used on the last one, if this is 3 pi fourths radians, that leaves me 1 pi fourth here, which makes us dealing with a 45, 45, 90 triangle. And so the cosecant of this angle, since cosecant is the reciprocal of cosine, being asked for the cosine of 3 pi fourths is the kind of code for saying what we really want here is the reciprocal of cosine of 3 pi fourths. Well, the cosine of 3 pi fourths would be the square root of 2 over 2. So if I have 1 over the square root of 2 over 2, that is equal to 2 over the square root of 2. And as much as you might be tempted to leave that, since I said it's okay, watch what happens on this one if you get it out of there. Well, now on the top I have 2 square roots of 2, and on the bottom I have the square root of 2 squared, which gives me 2 and cancels, and that gives me the square root of 2, which is my answer. And we are finished with number 28. Number 38. Find the sine, cosine, and tangent of negative 270 degrees. All right. Well, again, this is talking in terms of the angle, but I tend to want to think just in terms of the unit circle, so let's just do this one without a triangle. And to me, it's easier to think about the quadrantal angles without triangles anyhow. So we're going to look at a pair of axes here to see where our angle lands. So negative 270 means I'm going clockwise, so this would be 90, 180, 270 puts me here. So in essence, this is asking me for the sine, cosine, and tangent of 90 degrees, because I'm in the same spot. It's going to give me the same values. So the sine of, in fact, let's use the actual angle they gave us. The sine of negative 270 degrees is equal to, and remember that's the y-coordinate at that location, so that's 1. And then the cosine of negative 270 degrees is equal to the x-coordinate at that location, which is 0. And the tangent at that location is sine over cosine. So that would be 1 over 0, which is clearly undefined. Then we go to 44, possibly the most important one of the examples out of either of these videos in terms of learning how to think about this type of problem, because these are classic trig problems here. Alright, our directions tell us to find the cosine and the cotangent of theta if the sine of theta is 1/4 and the tangent is less than 0. Well, the tangent less than 0 gives us a giant hint because it tells us what quadrant it narrows down the quadrants anyway. Again, all positive in the first quadrant, sine positive in the second, tangent positive in the third, cosine positive in the fourth. Well, since we were given that tangent is not positive, we would, for that reason, omit the first and third quadrants just off of that first piece of information. Well, then we go over to, I don't know what the last 3 mark was. Then we go over to this other fact they gave us, the sine of theta being 1/4. And the fact that that's true means that sine has to be positive, which only happens out of the 2 that are left in the second quadrant, so we omit the fourth quadrant. So that means that now we know how to draw our triangle, and that also tells us what sign our other 2 values have to be. Since sine is the only thing positive, that means that both of our other answers should be negative. And if I draw the triangle the right way, my triangle will keep me straight and remind me so that I don't make a careless error. So let's sketch a triangle oriented in that direction, and then label it with what we know from that statement, that sine of this angle, which we'll put here, which is where the origin would be, because I would literally be drawing it here. It's a little crowded over here though, so put my mark back on my theta, and the sine being 1/4, remember sine is opposite over hypotenuse, so I'm going to put the opposite here, hypotenuse there, then I have to figure out my third side so that I can answer the question. And that's 1 squared plus b squared equals 4 squared. So b squared equals 4 squared, which is 16, minus 1 squared would give me 15, if I can make a 5. And then take the square root of both sides, so b is the square root of 15. And we put that on our picture for our reference. And remember, if you're drawing the triangle oriented where it would be in the plane, that would give me a negative here. So you would go to the left and up, and the hypotenuse or the radius, the radius is always going to be positive. But now, because we want the cosine, it's important that we note that our horizontal motion there was to the left. The adjacent is the square root of the negative square root of 15, and our hypotenuse, which is what goes on the bottom of cosine, is 4. Then we want the cotangent, which is the reciprocal of tangent, and tangent's opposite over adjacent, so this one will be adjacent over opposite, which gives me negative square root of 15 over 1, aka negative square root of 15. And that ends our videos for the 4-3 study guide and this video.